Okay, so this is week 5 for quantitative reasoning co-req, and this will be the video to help you out for this week and next week. So it's going to be all of chapter 4. So what we're going to cover today, we're going to talk about order of operations first, proportions second, equations dealing with percentages, and then solving linear equations, and finally we're going to evaluate some radicals. In case you want to know what radicals are, those are just like square roots, things to the third root, and so on. Okay. So the first thing we're going to talk about is order of operations. More than likely, you probably heard of PEMDAS before. So whenever we simplify equations like this one below, we always start with everything in the parentheses. Then we do exponents, multiplication and division at the same time. So they're on like the same level. And then addition and subtraction at the same time as well. Okay. And then the other order that you need to worry about is you always work from left to right. Left to right. Okay. So whenever you deal with parentheses, you deal with the leftmost parentheses first, and then go all the way through the equation and deal with the next ones. Okay. And whenever you're working with exponents, you do the same thing. Multiplication and division, you do at the same time, but you work left to right. And then addition and subtraction are the same. You work left to right at the same time. Okay. Okay. This little pyramid here just shows you that you start at the top and you kind of work your way down. Okay. As a little bit of a kind of like the mnemonic device with PEMDAS. Okay. So for our example here, we have the quantity of 3 plus 2 squared minus 12 divided by the quantity of 3 times 2. So remember PEMDAS, the first thing we're going to do is work with the parentheses. So I see parentheses here and here. So I'm going to work with this one first, and then I'll go to this one. So we have 3 plus 2, which is 5. So I get 5 squared minus 12 divided by, and then I work with these parentheses, 2 times 3, which is 6. Okay. And then I see I have an exponent next, so I'm going to work with my exponents. So 5 squared is 25. Minus 12 divided by 6. Okay. And then I see the next thing is I have division here and I have subtraction here. Now remember, division we always do before subtraction. So I'm going to do my division next, which is 12 divided by 6, which is 2. And then I'm going to rewrite everything else. So 25 minus 2. And then finally we have subtraction last, so we get 25 minus 2, which is 23. Okay, if I have, let's say I have like a huge fraction here, so maybe I'll just make one up. Maybe I'll have the same thing, 3 plus 2 squared on the top, and I'm going to subtract maybe 8 plus 4. I can do something like that. And then on the bottom of this, maybe I have 5 minus 4 divided by 2 multiplied by 3. So how I would simplify this is I would pretend that this division, the top divided by the bottom here, imagine that the whole thing on the top is in parentheses, and the whole thing in the bottom is in parentheses as well, because it's everything on the top divided by everything on the bottom. So I'm going to simplify the top as much as I can, and then simplify the bottom as much as I can. So we already know that 3 plus 2 is 5, 5 squared is 25. So I know that's 25. So I have 25 minus 8 plus 4, which is 12, divided by, and notice that I have a division symbol and a multiplication symbol on the bottom. So I'm going to have to deal with those first before I do the subtraction. So I'm going to leave 5 minus something at the bottom still. And then I'm going to simplify this. So I always work left to right. So I have 4 divided by 2, which is 2. 2 times 3 is 6. Okay. And then the next thing I can do is let's simplify the top and simplify the bottom, because remember they're still in parentheses. Okay. So 25 minus 12 on the top is 13, and 5 minus 6 is a negative 1. Okay. And now that I have just a number on the top and a number on the bottom, I can do that operation, which is division. So 13 divided by negative 1, we get a negative 13. Okay. Okay. So the next thing we'll do is talk about proportions. So proportions, you're just comparing two things together. And I guess the best example would be if I had, let's just say, a pizza, right, and I cut it in half, and I say I want 1/2 of this pizza. Well, what is the same thing as 1/2 if I cut it into fourths instead? So I want to say that that half of the pizza is equal to, maybe I cut it in fourths this time, right? So how many fourths is equal to 1/2? Well, I can just see by visual inspection it's going to be 2/4, right? But maybe I didn't know that. Or maybe we have, maybe it's cut into a lot more slices, right? So it's not as simple. Well, how I would do that was to say, well, 1/2 of the pizza is going to be the same thing as some amount of fourths, right? But I don't know how many fourths yet, right? So I don't know how many fourths. Well, what I can do is I can solve for that variable to find out how many fourths. And the way I can do that is we can cross multiply, right? So we can multiply the tops and multiply the bottoms. And all that means is that I'm just multiplying by 2 on both sides, right? And I'm multiplying by 4 on both sides. So if I do that, on the left side we get 1 times 4, which is 4. And on the right side we get 2 times x, which is 2x. And then finally, to solve for x, we divide by 2 on both sides, and we get x is equal to 2, right? Which is exactly what we saw in the picture. Okay, let's try another one. So maybe I say, maybe 3/8. What is that equal to in, maybe we'll do something over 32. So how many slices of pizza is equal to 3/8 of a pizza if I slice it 32 times, right? So what we'll do here is we multiply by 32 on both sides, right? Because that'll get rid of these two 32s. And then we multiply by 8 on both sides, right? Because that'll get rid of both of these 8s. So it's just the same thing as cross multiplying. So we get 32 times 3 on the left, which is 96. And on the right, we get 8 times x, right? And then we just divide both sides by 8. So those will cancel. 96 divided by 8. We get x is equal to 12. Right? So if I have 3/8 of a pizza, that's the same thing as 12 over 32 slices of pizza. Okay, let's try one more, and maybe this is a word problem. So maybe I say I can write, let's say 15 words every 2 minutes. So if I can write 15 words every 2 minutes, how many words can I write in, let's say, 10 minutes, in 10 minutes? Right, so my first proportion is 15 words every 2 minutes, or my first fraction, rather. So 15 words in 2 minutes. And I want to say, well, how many words, so an X amount of words, can I write in 10 minutes? Okay. And it should be pretty obvious, but I'll let you try to work that out yourself. But you should get, let's see, 75 words a minute. Or every, so 75 words in 10 minutes, rather. So you should get 75 words in 10 minutes. Okay. Okay, so the next thing we'll work on is percent equations. So I'll do that on the next page here. So percent equations, all that is you're just finding percentages of certain numbers. So it's similar to proportions, but we'll use percentages instead. So maybe a good example I could have is what is 50% of 100? Right? So what is 50% of 100? Well, that should be pretty easy, right? That's just half of 100, which is 50, right? But the question is, how did I know that? Well, 50%, we could change that to a decimal, right, of 0.5. And we could just multiply those together. So we could say 0.5 of 100, and we get 50. But there's more types of examples for percentages, right? We could say, well, what percent is 23 of maybe 69, right? So to find that, what we could do is we could say, well, I know that I have 23 out of the 69 slices of pizza, right? And I want to know what percent that is. Well, if I divide those two, I get 0.3333 repeating, right? Forever and ever. So I get 0.3 repeating. So if I wanted to know what that was as a percent, that's pretty easy, right? We just multiply by 100%, and we get 33%. Okay. And then the last example that might be dealt with percent equations is what percent, or maybe, so 24, okay, so maybe a word problem I would want to use is if maybe we're tipping someone, right? If you're at a diner or something. So let's say we had a really fancy dinner, or maybe a medium fancy dinner, and you spent $20. Okay, so you spent $20, and the waiter was really nice. So maybe we want to tip them 15%. We want to tip them 15%. So how would I find out how much 15% is? Well, we know that my total bill, so maybe I just say X, so my total bill is going to be equal to, or I guess my tip, I'll write that as T for tip. So my tip should be equal to 15% of 20, right? $20. So 15% is 0.15 as a decimal, and we can multiply that by 20%, right? And if we do that in our calculator, 0.15 multiplied by 20, we get $3. Right, so my tip should be $3 to be 15% of the price of the meal. Okay, so we talked about percent equations, so the next thing we'll talk about is solving linear equations. So you may be wondering, or maybe you already know, what a linear equation is. So a linear equation is when you have the variable. So linear equation is when the variable in the equation is to the first power. So it's to the first power. So basically what that means is that we have maybe just an x, right, which is to the first power. It's just implied, right? Or we could have maybe y to the first power, or maybe we have a to the first power, right? Any of the variables. We could have z to the first power, right? Which is just the same thing as just z, right? So those are our linear equations. So if you graph them, they'll make a line. Okay. Okay, so solving linear equations. Let's see. Maybe we'll have solve for x. Right. So maybe that's something that they'll ask you. Solve for x, and maybe we'll do 7x minus 7 equals 0. Right. So if I want to solve for x, the way I can do that is just doing the inverse operations to get it by itself. Right. So we're just trying to get the x by itself and everything else on the other side. So what I would do to solve for x here is, remember when we talked about PEMDAS, and we had like this triangle and we went up like that? Well, the first thing we do, since we're going backwards now, since we're solving something, is we're going to do our addition and subtraction first. And then we'll do multiplication, division, exponents, and finally parentheses, right? So we're going to do addition and subtraction first when we're solving for it. So we're working our way back up. So I see that I have a -7, or subtract 7 here. So to get rid of that, what I'm going to do is I'm going to add 7 on both sides. Right? So then I just have 7x on this side, equals 7, right? 0 plus 7 is 7, and these two cancel. And then 7x equals 7, so I'm going to divide by 7 on both sides, and we get x equals 1. So that was pretty easy. What if I want to do maybe something a little bit more complicated? Maybe I want to do x over 4 plus 3 divided by 4 equals 1. Or maybe I'll do divided by 5 equals 1. So now the question becomes, what do I do, right? And maybe I'll have this whole thing divided by 5, right? So what do I do? Well, the first thing I see is that I do everything in the parentheses last, right? Since it's at the top. So I'm going to do addition and subtraction first. Well, there's nothing outside the parentheses that's addition and subtraction. So then I move up to multiplication and division. Well, I see I have this 5 here, right? So what I'm going to do is I'm going to multiply by 5 on both sides, right? So if I multiply by 5 on both sides, this cancels. 1 multiplied by 5 is 5. Right? So we get x over 4 plus 3 equals 5. Equals 5. And now I see I do have an addition and subtraction now, right? So I'm going to start at the bottom, addition and subtraction. I'm going to subtract 3 on both sides. And I get x over 4 is equal to 2. Right? And then I have this divided by 4. So to get rid of that, I'm going to multiply by 4 on both sides. So x equals 8. Okay. So that's solving linear equations. I'm just trying to get the variable on one side and everything else on the other side. Okay, and the final thing we'll talk about is evaluating radicals. So evaluating radicals, all we're doing here is I'm going to say, hey, I want the square root of 100, okay? And if I ask you for the square root of 100, I'm sure you've done it before. You can do it on your calculator as well. All this is saying is what squared equals 100, right? So if I take the square root of 100, that should just be 10, right? But maybe I'll have some more complicated ones, right? Maybe I'll have the cube root of, let's say, 27, right? So I'm saying what to the third power is equal to 27, right? So what times itself 3 times is equal to 27? Well, the cube root of 27 should be 3, right? So maybe some terminology that would be helpful. I'll write this over here. If we have something like this, that's just the square root. If I have something like this and then you have a 3, that's a cube root, right? If I have something with a 4 there, that's just a 4th root. Right, and this can go on and on forever, right? So we could have something like that. And that just means the nth root, right? It's just some number. So that's just the nth root. Okay. So we can continue this pattern on for as high as we want to get, right? Okay, so you might have a question. What if we have a negative in here, right? So what if we have, hey, what's the square root of a negative 10? Or maybe negative 100. That would be even easier, right? So what times itself is going to equal negative 100? Well, anything times itself, so if I have some number multiplied by itself, if it's a negative number, right? So let's say we have a negative 10 in here and a negative 10 in here. Well, negative 10 times negative 10 is a positive 100, right? And if I have a positive 10 and a positive 10, that's still a positive 100. So what I've noticed is that there's no real number. So there's no real number that will satisfy this, right? There's nothing that I can multiply together that's a real number that'll equal to negative 100, right? But that only works for square roots, right? Or maybe it'll work for 4th roots or 6th roots, okay? So if you ever have a negative number under here, with an even root, so square root, fourth root, sixth root, and so on. So if you have a negative number with an even root, there is no solution, right? There's no real number that you could plug in there to get that. You could have a real solution for something to the third root or the fifth root or so on, right? You could have something when you have an odd root. So if you have a negative with an odd root, you could have a solution. And in fact, you will have a solution every time, right? You just have to find out what it is.